Even and odd functions and graph symmetry. An even function is a function where if you replace the x with the opposite of x, the function will simplify to the same as the original function. The graph of an even function is going to be symmetric with respect to the y-axis. In other words, if you were to fold the graph on the y-axis, the left side and the right side of the graph are identical. They would match up. So, let's consider the graph of 4x squared minus x to the 4th minus 3. Let's replace the x with the opposite of x. So that's going to give us 4 times a negative x squared minus a negative x to the 4th power minus 3. Now you've got to really watch your signs here on this problem. When you square a negative x, it's going to end up just a positive x squared minus, when you raise a negative x to the 4th power, anytime you raise a negative to an even power, it's going to end up positive. So, we do end up with an equivalent function to the function we started with. So we would consider this an even function. Now, if we look at the graph, notice that here is the y-axis. And if you look on the left side and the right side, the graph is identical over here as it is over here. So we do have symmetry. We call it symmetry with respect to the y-axis. Now, when you have a function and all of your terms have even exponents, all of your x terms have an even power with it, even if you have a constant term in there, you're going to have an even function. And that's what we had on this problem. We had even exponents with our variable. We did have a constant term in there, but we didn't have any x to an odd power. So the function was even. If we look at odd functions, an odd function is symmetric with respect to the origin. So it has a different kind of symmetry. And with an odd function, if you replace the x with a negative x, you don't get the same as the original function, but you get the opposite of the original function. So here, if you change the sign of x, it will also change the sign of the y. So let's look at and test to see if a function is odd. Here, f of x is negative 2x to the 5th plus x to the 3rd plus 5x. If I replace my x with a negative x, I'm going to have negative 2 times a negative x to the 5th power plus a negative x to the 3rd power plus 5 times a negative x. Now in this problem, all my exponents are odd. So when I raise a negative to an odd power, it's going to end up negative. So this will be negative 2 times my negative x to the 5th power. So that's going to give me 2x to the 5th power. Then I'm going to have plus a negative x to the 3rd minus 5x. So I have 2x to the 5th minus x to the 3rd minus 5x. This function is the opposite of our original function. This was the original function. If I multiply it by -1, I get f of negative x. So that tells us this is an odd function. And if we look at our graph, this has what we call symmetry with respect to the origin. Now, it's a little harder to see, but if you think of taking one side of your graph, well, or think about rotating the graph 180 degrees. In other words, take the whole graph and just turn it 180 degrees. You would end up with the same graph. It's almost like you flip it over this way and then flip it over this way. That's what symmetry with respect to the origin would look like. Now, similar to what we talked about with an even function, if you have only odd powers with your x, then it is an odd function. So if we look at this example, I only have odd powers. But if I replace my x with a negative x, I'm going to have 2 times a negative x cubed minus a negative x plus 2. Well, my first term will be negative 2x cubed. My next term will be plus x, but the plus 2 remains a plus 2. So what happens here is the sign of these terms change, but the sign of this one did not. So that means this is not an odd function. It also is not even. Okay, it would be considered neither even nor odd. So odd functions cannot have a constant term in it. There's one more type of symmetry. We talked about even functions having symmetry with respect to the y-axis. Odd functions have symmetry with respect to the origin. You also can have functions or graphs, not a function, but a graph that has symmetry with respect to the x-axis. This is an example of a graph that has symmetry with respect to the x-axis. It is not a function because it does not pass the vertical line test, but it is an example of a graph that has symmetry with respect to the x-axis. If you fold it along the x-axis, the part above will match up to the part below the x-axis.